Welcome, this is Cambridge A-Level 9709, October-November 2022, paper 52, Probability and Statistics. Coming to the first question. So what is the first question is saying about? The first question is says, on any day, Kino travels to school by bus, by car or by foot, by the probability is 0.2, 0.1 and 0.7. The probability that he is late when he travels by bus is x. The probability that he is late when he travels by car is 2x. And probability that he is late when he travels by foot is 0.25. On a randomly chosen day, he is late. So he can be late by traveling by bus or by car or by on foot. So 0.25 equals to 0.235. Simplify that. You should be getting it out. 0.2x plus 0.2x equals to 0.235 plus 0.7 times 0.25. So x equals to 0.235 plus 0.7 times 0.25 divided by 0.4. Simplify that, you should be able to get that answer 0.15. Find the probability that on a randomly chosen day, Kino travels by the car given that he is not late. So probability of car and not late. So probability of car and not late divided by probability of not late. Probability of not late is 1 minus late. What was the late over here? 0.235. 0.235. Now car and late. He's traveling by car is 0.1 and not late. Not late is 1 minus 0.3. Because late by car is 0.3. So this is 1 minus 0.3. How I got 0.3? Because for car it is nothing but how much? 2x. 2x. So 2 times 0.5. 0.15, which is nothing but what? 0.5. So this is late by car. Not late by car will be 1 minus 0.3. Simplify that. You should be able to get that answer as 0.0915. Next question. The lengths of the roads produced by a company are normally distributed with mean and standard deviation. In a randomly chosen 400 of these rods, how many would you expect to have less than 54.8? So probability of x less than 54.8. So probability of z less than 54.8 minus 55.6 divided by 1.2, which is probability of z less than negative 0.667. So 1 minus probability of z less than 0.6667. So 1 minus 0.7477, which is 0.2523. Find the probability that the randomly chosen rod produced by this company has a length that is half within the standard deviation from the mean. So same way, probability of mu minus 1.5 standard deviation x and mu plus 1.5 standards of standard deviation. So you have to be very much careful over here. Whenever it is lies between, so what does it becomes? Second number minus first number divided by standard deviation minus probability of z less than mu minus 1.5 sigma minus mu upon sigma. So what does that happens there? Mu and mu gets cancels, then sigma and sigma also gets cancels. So what am I left over with? Probability of z less than 1.5 minus probability of z less than negative 1.5. So probability of z less than 1.5 minus 1 minus probability of z less than 1.5. So it become 2 probability of z less than 1.5 minus 1. So 2 times 0.6915 minus 1, which is 0.383. Question number 3. 3 fair 6-sided dice with each faces 1, 2, 3, 4 are thrown at the same time repeatedly. The score on each throw is the sum of the numbers on the uppermost face. Find the probability that the score is 17 or more in the first operand 6th throw. So it should be probability of x equals to 17 or probability of x equals to 18. So it has to be either be 17 or 18. So how should I be able to get that 17? How can I get 17? 18 is nothing but what? 666 is 18. So I have to decrease it 1. So it becomes 665 or 656 or 566. So totally how many ways are there? There are 4 ways. So this is 3 upon 6 times 6 times 6, and this is only 1 upon 6 times 6 times 6, which is nothing but what? 4 upon 216, which is 1 upon 54. This is a probability of success, that it should be obtained in the 6th throw. So probability of x equal to 6. So 5 times he should fail and 6th time he should win. That's going to be the answer. This is probability of success. So probability of failure will be 53 upon 54. 5 times he should fail and the 6th time he should be success. Simplify that, 0.0169. Find the probability that the score of 17 or more is obtained in fewer than 8 throws. So probability of x less than 18. So it should be 1 minus failure. How many times? 7 times. So whole to the power of 7, which becomes 0.123. Next one, the time taken in minutes to complete a word processing task by 250 employees at a particular company are summarized. Draw the histogram. So for drawing the histograms, I should first of all know frequency density. So frequency divided by the class width. So what is the class width over here? 20, 20, 10, 10, 40. So 32 divided by 20 is 1.6, 2.3, 9.6, 5.2, 0.6. So what am I going to do? I'm going to mark it out over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is time taken per minutes. And this is frequency density. Now 0 to 20 it is 1.6. 0 to 20 it is 1.6. And before that 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. 0 to 20 it is 1.6. Then 20 to 40 is 2.3. Then 40 to 50 is 9.6. Then 50 to 60 is 5.2. Then 60 to 80 is 0.6. 60 to 100. From the data, calculate the standard deviation. The mean is 250 is 43.2, and he is asking us to calculate the standard deviation of this one. So what am I going to do that? First of all, calculate the midpoints. Midpoints are 10, 30, 45, 55, and 80. So standard deviation will be square root of 32 times 10 square plus 46 times, let me write it out in different font, 32 times 10 square plus 46 times 30 square plus 96 times 45 square plus 52 times 55 square plus 24 times 80 square divided by 250 minus the mean square 43.2 square, which is nothing but how much? 18.3. Question number 5. Eric has 3 coins. One of the coins is fair. The other 2 coins are each biased, so that the probability of obtaining heads on a throw is 1 upon 4 independently of all the 3 throws. Eric throws all 3 coins. Events A, all the 3 coins show the same result. Event B, at least one of the biased coins shows a head. Show that probability of B is 7 upon 16. So what is he telling it out? He has how many coins? First of all, 3 coins. One of the coins is fair coin. The other 2 coins are biased, so that the probability of getting a head is 1 upon 4. So for this, probability of getting biased head is 1 upon 4. So probability of getting biased tail will be 3 upon 4. Now what is he asking? He is asking that B, at least one of the biased can show a head. So biased can show one head and the another one will be showing it a tail, or else first one is showing first biased coin is showing a tail, the second one is showing a head, or else both are showing head. The first biased coin is showing a head, second biased coin is also showing a head. So this is 1 upon 4 times 3 upon 4, which is 3 upon 16. This is 3 upon 4 times 1 upon 4, which is 3 upon 16. This is 1 upon 4 times 1 upon 4, this is 1 upon 16. So total will be 3 upon 16 plus 3 upon 16 plus 1 upon 16, which is 7 upon 16. Probability of A given B. So first of all, we should be knowing it out. What is probability of A? All the 3 coins show the same result. All the 3 coins show the same result. Let me write it all over here. Probability of A given B is probability of A intersection B divided by probability of B. Probability of B, just now we got it out, 7 upon 16. A intersection B. What is the meaning that all three are showing the same result? All three are showing the same result means the first one is also head, second one is also head, and the third one is also head. So it is 1 upon 2 times 1 upon 4 times 1 upon 4. Because here 3 cannot be the same because they are already different in this case. In this case, they are already different. In this case, they are already different. So these two are not possible. So only the way is head, head, and A is also showing you an head. So 1 upon 2 times 1 upon 4 times 1 upon 4 divided by 7 upon 16. Simplify that, which becomes 0.0714. Next, the random variable X is the number of heads obtained when Eric throws 3 coins. Draw the probability distribution for X. So, random number of heads. How many heads it can be there? Because 3 coins, right? So it can be maximum is 3 heads. So minimum is 1 head. 0, 1, 2, 3. Probability of X. Now 3 heads. Just now we have done 3 heads is nothing but how much we have done 3 heads is 1 upon 32. We have done 1 upon 32. 0 heads. 0 heads means nothing but how much? Probability of 0 heads. 1 upon 2 and it is 3 upon 4 and 3 upon 4. So it becomes 9 upon 32. Now 1 head. So it can be head, tail, head, head, tail, 1 head. So what am I going to return? 1 head, tail, tail, or tail, head, tail, or tail, tail, head. So what is this will be? 1 upon 2 times tail is 3 upon 4, 3 upon 4, or else this will be 3 upon 4 times 1 upon 2 times the second one. what am I doing it out is in this way. If at all I do it out in this particular way, it will be able to get that answer. Otherwise, you will be able to get a wrong answer. So let me write it out neatly over here. One head. So we are getting it out one head. So we have a fair coin, biased coin, and a biased coin. So fair coin is a head, biased coin is also a head, and is a tail, and biased coin is also a tail. Fair coin is a tail, biased coin is a head, and this is a tail. And this is nothing but what? Tail, tail, head. So for that, how should I be able to do that now? This is 1 upon 2. Tail is 3 upon 4, 3 upon 4. This is 1 upon 2. Head is 1 upon 4. Tail is 3 upon 4. Tail is 1 upon 2. Tail is 3 upon 4 for biased. And head is 1 upon 4. Add them all. This will become 9 upon 32 plus 3 upon 32 plus 3 upon 32. So it is nothing but how much? Well, 15 upon 32. So one head is 15 upon 32. Sum of all probabilities should be 1. 9 plus 15 is nothing but 24. 24 plus 1 is 25. So this one has to be 7 upon 32. This is the probability distribution table. Question number 6. At a company's call center, 90% of callers are connected immediately to a representative. A random sample of 12 callers is chosen. Find the probability that fewer than 10 callers are connected immediately. Probability of x less than 10, which is very difficult to do. 1 minus probability of x equals to 10 minus probability of x equals to 11 minus probability of x equals to 12. So 1 minus 12c 10. 90% are calculated. So success is 0.9, failure is 0.1. 0.9 to the power of 10, 0.1 to the power of 2 minus 12c 11, 0.9 to the power of 11, 0.1 to the power of 1. 12c 12, 0.9 to the power of 12, 0.1 to the power of 0. Simplify that, 0.111. Part B, a random sample of 80 callers is chosen. Use an approximation. So for that, more than 69. N is 80. So find mean. Mean equals to NP. So 80 times success is 0.9. 0. What does it become? 72. Then standard deviation is square root of NPQ. So which is square root of 80 times 0.9 times 0.1, which is square root of 7.2. So probability of x greater than 69. Greater than 69 means when you convert into z, it becomes 69.5. 69.5 minus 72 divided by square root of 7.2. So probability of z greater than minus 0.9317. So 1 minus probability of z less than minus 0.9317. 1 minus probability of z less than 0.9317. So which is 0.824. Next, justify the answer of the approximation of part B. So therefore, NP equals to 72, NQ equals to 8. Both are greater than 5. So therefore, approximation is valid. If at all they are greater than 5, the approximation will be valid. Question number 7. Find the number of different arrangements of the letters in the word alligator in which two A's are together and two L's are together. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units are there, right? So 9 units. Two A's are together. So minus 2 A's minus 2 L's plus 2 A's together as 1 unit and plus 2 L's as together 1 unit. So 9 minus 4 plus 1 plus 1. So which is nothing but what? 7 units. 7 units can be arranged in how many ways? 7 factorial, which is 5040. Coming to part B, the 9 letters in the word alligator are arranged in random. Find the probability that two L's are together. So I take 9 units minus 2 L's minus 2 A's, and there are 6 letters between 2 A's. So 2 A's So totally how many units are there? 5 units are there. These 5 units can be arranged among themselves in how many ways? 5 factorial ways. There are two A's, and between those two A's, there should be 1, 2, 3, 4, 5, 6. If at all 6 alphabets are there, you can see that those two L's can take place as 1, 2, 3, 4, 5 places. First and second place, second and third place, third and fourth place, fourth and fifth place, fifth and sixth place. So totally how many ways those two L's can be placed is together? They can be placed in 5 ways. Times again 2. They can be swapped together. Again it is times 2. So totally how many ways? 1200 ways. But he is asking about probability. So probability is 1200 upon total number of ways. What is total number of ways? 9 factorial upon 2 factorial, 2 factorial, which is going to be nothing but how much? 90,720. Simplify that, you should be getting 0.0132. That's going to be the answer. Now part C, find the number of different selections of 5 letters from the 9 letters alligator which contains at least one A and at most one L. So it can be A and no L. So it has to be done in 5C4, which is 5 ways. 2 A's and no L. It is done in 5C3 ways, 10 ways. 1 A and 1 L. So remaining 3 more, 5C3. 2 A's and 1 L. 2 more, so 5C2, which is 10 ways. So totally how many ways? It's going to be 35 ways. So that's going to be the answer. So that completes the paper. See you in the next paper. Bye.